So I'll start by explaining this again, even though it's written. Proof by exhaustion. When you exhaust something, it means what? What? You used everything, right? You consider everything. So when you prove by this, it means you consider all the possibilities, and when you do that a lot. In my current thesis that we are working on, I could remember at a point some of the papers that I read while I was trying to do my work. It has to do with, consider the case of this, the case of this, and all the cases has to be proved. Nobody will tell you use contradiction when you get to university. Use contrapositive, use exhaustion. You will look at it and you consider, maybe I can use this, maybe I can use that, and whatever works. All these proofs are allowed in mathematics. So let's quickly look at it. Like I said, to complete the proof, that is the original proof, all the possible cases must be exhausted. That is, by showing their proofs. So if there are 5 possible cases, you must take them one by one, and all the 5 must be proved. Then you have exhausted all the possibilities, and that means you are proved by exhaustion. Does it make sense? Here is an example. But before we go to that, this statement, we use this a lot. A divides B, or B is divisible by A. They are the same. Okay? When you say A divides B, 2 divides 10, because 10 is divisible by 2. This is how we write 2 divides 10. It's just a vertical line. Okay? 2 divides 10. Which means 10 is a multiple of 2. Right? So which means this implies that 10 is actually some k2. In this case, k is 5. Does it make sense? Or 2k. Okay? So I'm going to be using this, which is why I decided to quickly put it here now. So henceforth, this is what I'll be using when we're talking about divides and divides and divides. Okay. Given that, so they've been kind enough to give you the factorized version of n to the power 5 minus n to make life easier. Okay? Prove that any number in this form, for any value of n, this will always be divisible by 5. Which means this must be a factor, a multiple of 5, basically. Do you understand that? I want to prove this quickly. So, I say proof. I need attention. Nobody should write. No one should think of something else. So I start by looking at all numbers. Remember, this is for all integers, right? When you divide any integer by 5, well, let's consider what remains. What are the possible remainders that you have? If you divide any number by 5, what are the possible remainders that you have? You can have 1. Give me an example of the one that gives 1. 6. Yes?
1, 2, 3.
1, 2, 3, 4. What else? 0. What else? Any other option? Are you sure? There's no 6? Why can't you have remainder of 6?
Divide by 5.
Because I still divide by 5. So, all the possible remainders when you divide by 5 are 0 to 5. No, 0 to 4. Okay? So, we start by saying, let n be a number. Of course, like we've been given. Okay? When n is divided by 5, yes? The remainders are 0, or let me say the possible remainders, or the possible remainder, 0, 1, 2, 3, and 4. And that tells us something, that actually this implies that n could be in the form what? Based on this, n could be in the form what? Based on when you divide any number by 5, the remainders will be 0, or 1, or 2, or 3, or 4. So how can we write any number n in terms of that 5? Yes. There are different forms. Give me the first one, based on the last statement. Yes? 5k 5k plus 1. Do you remember? Do you understand this? 5k's are the one that leave remainder of 0, which means the factors of 5 itself. Yes? Yes? 5k plus 2. I mean the multiples of 5. 5k plus 3 and 5k plus 4. These are the possibilities, the possible values of n, the possible forms of n. Okay? Okay? We want to prove that this is divisible by 5. Then we consider each of the possibilities. To prove that n to the power 5 minus n, which of course we know to be what? N minus 1, n, yes? N plus 1, n squared plus 1 is divisible by 5. I should have said 5 divides. For all n, right? This is for all n. Of course, the last statement is not necessary when you're writing. This is just me trying to explain my words. Okay? We consider possibilities. So I can call them cases now. Case 1. If n is in the form 5k. Okay? Because we have said that any number divisible by 5 will take some forms. Okay? So because the problem is about being divided by 5, that's why we consider number, if all numbers are divisible by 5, what happens? Are divided by 5, what happens? So if n is of this form, can you tell me how that proves that the above is divisible by 5? If n is of this form, remember any number will be of these forms. And we are trying to consider for all numbers. So if we are trying to consider for all numbers, if we are able to prove for these 5 cases, then we are proof for all numbers, because we just confirmed ourselves that every number that we know of is of this form. Do you understand that? So if we are able to prove for these 5 cases, then we are proof for all numbers. Does it make sense? So if you take the case of 5k, how can we show that this is divisible by 5? Anybody? Let's speak. We substitute. If you substitute, this is clear. Isn't it? Because 5k will be here, which means 5 can be outside the factorization, right? Isn't that what it means to be divisible by 5? So that's sorted. That's easy. Okay? Now, I will write the proof because of the time, but I want us to go through with it. Do you understand? Are you lost?
No, she was saying something.
Okay. If this is about this, let me know. I want everybody to please pay attention. What about this case? How can that case prove it?
Substitute the first one.
We substitute in, no, your substitution is not here. Your substitution is in everything. I'm only saying this is what makes it trivial. You put 5k here, minus 1. But of course, that does not have 5 outside the bracket. You put 5k here. Oh, 5 can be alone. As long as 5 can stand alone, then we can establish that it is divisible by 5. Do you understand it now? So it's not just substituting into the first one. We actually substitute into all of them. But one of them, one of these factors will generate what we need. Yes?
That's what I mean, like 5k.
Aha. So the first one will take care of it. Even if others cannot produce 5 outside their bracket, this will take care of it in this case. Because the moment you put 5k plus 1 and minus 1, oh, 5k can stand alone. Does it make sense? And whether the rest can produce it or not, nobody cares. As long as you can get 5k. Does it make sense now? Are you lost? Kind of. When a number is divisible by 5.
I get that part, but like when you say it's divisible by something, there can still be remainders.
No.
Then what does that first sentence mean?
When any number is divided by 5, these are the remainders. We established that. And from this, we were able to say that every number we can write it in this form. Do you agree?
Oh, okay.
5 is like this. 10 is like this. 6 is like this. 11 is also like this. 21. Yes? 7, 12, 22. They are in this form. 13, 23 in this form. This is like 24. Every number you pick falls into this category. Any number. 107. Oh, it's of this form. Because this is 105 plus 2. Okay? So we are saying that to be able to prove that this is divisible by 5, we have to be able to prove by that each of these, okay, divides this.
So all of those are
We have to prove, okay, wait, all numbers are like this. That for every number, this is divisible by 5. And these are all the numbers. This 1, 2, 3, 4, 5 represent all the
So
numbers.
it doesn't mean all 5 works.
That's what it works. That's what we want to establish.
Oh, it works?
Yes, that's what we are doing one by one.
Wait, so every number is divisible by 5?
This expression is divisible by 5 for all numbers.
Oh.
And this group, 1, 2, 3, 4, 5, represents all numbers. So if for all these 5 cases, we can prove that this is divisible by 5, then we have proved that for all numbers, it is divisible by 5. Does it make sense now? So we have taken this. If you put here, okay, if this happens, if n is 5k, then n squared, n to the power 5 minus n would be equal to 5k minus 1, yes? 5k, 5k plus 1, 5k squared plus 1. Is this divisible by 5? Yes, because 5 can be out of the bracket. 5 can be in front. It doesn't have to be in front anyway, it could be there. As long as 5 can stand alone, we are good. It's like writing 2 times 5 times 3. Is this number divisible by 5? Yes, because we can see a 5 standing alone with products. That's the point. Okay, so we can just say this, which is divisible by 5. You can just write that statement, which is divisible by 5. So that's the first case. So the second case will be if n is of the form 5k plus 1. That also works, because 5k plus 1 minus 1 gives you 5k. Regardless of what the rest will give you. Of course, you write the rest, but you don't have to expand. You don't have to come here and write 25k squared plus 1. Nobody needs that. As long as your 5k is out, nobody cares what the rest looks like. What about 5k plus 2? Anyone?
Oh, the last one.
The last one.
Yeah.
Because it doesn't work for this. 5k plus 2 minus 1 will be 5k plus 1. 5k plus 2, well, nothing like 5k, because it has to be factorized out of the O bracket, right? 5k plus 2 plus 1 is 5k plus 3. It doesn't seem to work. Well, maybe this one. Then you check it. What is 5k squared? This is where you now expand. What is 5k squared? 5k plus 2 squared. That will be 25k squared plus 20k, right? So the first two terms can give you 5, right? Then the last one will be plus 4. Then you already have 1. Then your 5 can be factorized out. But until you are able to factorize out, do not write which is divisible by 5. Okay? Then what about 5k plus 3? Note that the first two terms will give you factors of 5. 3 squared will be what? 9. So the last term is 9. Then plus 1, 10. 5 can still be out. Which of these factors will solve this problem for you? N plus 1.
Okay.
And you see that all the options are exhausted. So every number in this form is divisible by that, right? Any number in this form divides it. Okay, if the number is like of this form, this is divisible by 5. If the number is of this form, and we know that these are all the possibilities of all the numbers that we know. Which means, indeed, for all numbers that exist, this expression will always be divisible by 5. That's what we mean by proof by exhaustion. Any questions? So I'm going to write complete proof while you go on break, or maybe I let you do it. Is it okay?
Yeah.
And show me how you write the complete proof. Remember what I said. You must be able to get to the point where 5k can be out of the bracket before you write which is divisible by 5. And when you are done, you can say, oh, therefore, for all numbers, that's just your last statement. Therefore, for all values of n squared minus n is divisible by 5. That's it. Any question?